In this example, we're going to notice that when we have something over the square root of 4 minus x squared, a good choice for u might be 4 minus x squared, which would give us a du of negative 2x, but that only deals with the x part. What do we do with the plus 2 part? Well, we might notice that the 2, a constant over the square root of 4 minus x squared, looks like something that might take us back toward the arc sine. So what we're going to do is break this integral up into two parts. We're going to say this is the antiderivative of x divided by the square root of 4 minus x squared dx plus the integral of 2 divided by the square root or 4 minus x squared dx. Another one of the many tricks to integrating is recognizing when you actually have multiple patterns showing up in the same problem. And then because we have a single denominator, a single expression, just the square root, it makes it easy to break it up into two different pieces using the addition that we had in the top there, basically breaking a fraction up into two fractions that we can add together. So let's go ahead and take a look at these pieces. In the first one, as we said, we can let u be equal to 4 minus x squared, and then du is equal to negative 2x dx, and therefore negative 1/2 du is equal to x dx, and that will give us a good substitution there. That will change this into the antiderivative with a negative 1/2 out front of 1 over u to the 1/2 du. If we do our substitutions there. On the other side here, we're going to have u is equal to x, du is equal to dx, but we have two dx's, so 2 du is equal to 2 dx, and we're going to note that a is equal to 2. So we'll write that as plus 2 times the antiderivative of 1 over the square root 4 minus x squared dx. And let's see what happens here. So we're going to end up with minus 1/2 times 2 times u to the 1/2. Right, I'm thinking of this as u to the negative 1/2, so I'm going to increase the power to 1/2 and multiply by its reciprocal, which is 2, plus 2 times the arc sine of x over 2 plus c. That is, I will get minus the square root of 4 minus x squared plus 2 times the arc sine of x over 2 plus c. So it's really two different problems mixed into a single problem. Two different kinds of u substitution going through there. Didn't really need it a lot other than just to clarify some things with the right-hand integral leading to the arc sine. But we are still able to completely integrate this and come up with a good answer. Go ahead and try to find the derivative of your answer and see if you end up with those two pieces from each part, which we then, because of the common denominator, could put together into the original integrand.